Alright, here's the question. What's the net force on the middle particle from the two on the end? Well, the two on the end are both positive and this one's negative, so that means the 20 microcoulomb is pulling on the negative 12 microcoulomb. And the 6 microcoulomb over here is pulling to the left on the 12. So 20 is pulling to the right, 6 is pulling to the left. That's because they're opposite charges. Opposite charges, we have tug of war. So this one is pulling to the right, to the left, to the left. That's F. Call that F1. And this one is pulling to the right. Call that F2. F1's negative because it's to the left. F2 is positive because it's to the right. What equation do we use? Well, we have to use F equals K, Q1, Q2 over R squared. And in this case, we have to use it twice. So F1 would equal 9E9 newtons meter squared per coulomb squared times Q1, which we'll just say is 6 e to the negative 6 coulombs. Notice we don't use the plus or the minus, just the number in the equation, times 12 e to the negative 6 coulombs. And then divided, how far apart are those? They're 20 centimeters, which is 0.20 meters. Don't forget to square. And that's going to give us a number. Let's see what that number is if I do it on my calculator. So 9 second e to the 9th times 6 second e to the negative 6 times 12 second e to the negative 6 divided by 0.2 squared. And I get 16.2. So F1 is 16.2 left. Now let's do F2. F2 is going to be the same thing, except a different number. 9.9, 9 times 10 to the 9th newtons, meters squared per coulomb squared, times Q1, which is going to be now 20 e to the negative 6 coulombs. This is the same, 12 e to the negative 6 coulombs. Again, notice I don't use the negatives or anything in here. We look at what direction by the arrows, what direction is it pulling or pushing it. See, if 20 was a negative, it would push to the left, but it's not, it's positive, so it pulls it. So that's going to be 0.1 meters divided by 100 to get meters squared, and that's going to give me a number. So F2 is going to equal, and let's see real quick. So 20 e to the negative 6 divided by 0.1 squared. I get 216. So y'all do these two and check me. These are just problems I made up. What I do with those two? Well, it's going to be F2 minus F1 because F1's negative, right? So 216 newtons minus 16.2 newtons is basically going to be 200 newtons right. That's basically what it's going to be. That's how you do one of those kind of problems. And then, of course, we could, if we wanted to, find the net electric field and all would we do with that? We'd have to know where we wanted to find it, but basically find an electric field with a point charge that's K, Q over R squared. And let me do the view a little bit better on this. View, zoom, let's do 75. There we go. So if we were talking about a point, let's say we're talking about, let me erase these F's here since we don't need them now. Let's say we're talking about a point right here. Now let's do this. Let's say we're talking about a point 10 centimeters. It'll be right in the middle. 10 centimeters from the negative 12. So from here to here would be 10 centimeters. Well, now how far is this one, is this point here, how far is it from this one now? Well, it'd be 20 centimeters, right? Because it'd be 10 plus 10. How far is it from this one? Well, it'd be 10 centimeters. So how do we find it? Well, let me get a different color here. The electric field it always goes out of a positive, so on this side of this positive, it's going to be pointing that way. This one is negative, so it's going to be pointing in. Remember, the electric fields go into negative and out of a positive. And then this one, it always goes out of a positive, so it's going to be pointing this way. So the 6 microcoulomb and the 12 microcoulomb both point to the right because of the direction of the electric field for a positive and a negative. This one points to the left, and all we have to do is put our numbers in. We'll call that E1, we'll call that E2, call that E3. We just plug our numbers in 3 times, the 3 different numbers. So I'll just leave it E. So E equals 9E9 newtons meters squared per coulomb squared times 6e to the negative 6 coulombs divided by how far apart they are. So 0.10 meters squared for that one. Remember, we're using the new numbers we found here for how far they are apart. I'm going to get a number. I'm going to repeat that. That's E1. E2 is going to equal 9e to the 9th newtons meters squared per coulomb squared times 12e to the negative 6 coulombs. Notice I don't use the negative in there. I have to look and see what direction the electric field is. That was also 0.1 meters from it squared. That gives me a number. Both these are positive numbers, by the way, because they point to the right. And then E3 is going to be 9e to the 9th newtons meters squared per coulomb squared times, that was 20e to the negative 6 coulombs. And this is divided by 20 meter, or 0.2 meters, sorry, 0.2 meters, and I'm going to square that distance, and I'm going to get a number, and it's going to be negative. So I'll let you do the math, but do this, you'll get a number, get a number, get a number, add these two and subtract that from it. That'll give you the net electric field from those 3 charges.